begin. So we have a question here which we have to solve. We have in triangle OPR. So check the triangle we have. We have OPR. Below the line OX produced. Okay, we have the line OX which is produced meets PR. It meets line PR at Y. We are able to see that point. Yes. Then PQ and OY meet at X. So look at PQ and OY meet at point X. Such that XQ, you have XQ is 1 over 3 of PQ. What does it mean? What does it mean? 1/3 of the vector we have at PQ. So if we were to put ratios, what does it mean? If XQ is 1/3 of PQ, 1/3 of PQ, meaning the total is 3. So if this is 1, then for it to make 3, for this one to make 1/3 of PQ, meaning here it's what? 2. That's what it means. So that's why we can express this one as 1 over 3 of PQ. Clear there? Yes. Okay. Then we go to OP. We've been given OP is vector P, OQ is vector Q. So OQ is vector Q. But again, there is this last point saying OQ is equal to QR. Very important. What does it mean if OQ is equal to QR? What does it mean? So what is here is what is also where? So we have saying Q, isn't it? No, it's okay, it's factoring even if not sure. So meaning even here we have vector Q, isn't it? That's what it means. So we are told now to say express in terms of P and or Q as simply as possible. Question A, vector PQ. Vector PQ. So we need the path, isn't it? Yes. So how do we move? Remember I explained to say for vectors, if you want to understand clearly, think of there is no path here. You want to move from P to go to Q, but there is no path here. You have to create that path, isn't it? Yes. So how are you going to move? P. So let's have our solution here. So this is question E. So we have question 1. Yeah. So let's see. Someone is saying we move going this side. PR. Why can't we use PR? Okay. So let's use P O. Exactly. It has to be negative. So we say vector PQ, we have to PO, meaning negative, PO, then plus. Why plus Q? So we have OQ. So your job is simply to substitute. So what is one? OP? So since it's P, so we have PQ. We have it will be negative P. Then plus OQ. Vector Q. So you can start with the positive vector which is Q, then minus P. So there you are, done. The first one. We go to the second one, which is OX. OX. Good. Which is number 2, right? no path. You have to create it. Okay, so we have OQ, which will be positive, right? Yes. Then we have QX. Now let's analyze it. Is it going to be negative or positive? Negative. Why negative? Why is it going to be negative? Go back in the statement, the question. Did they mention PQ or QP? It will tell you whether it will be negative or positive. So he has seen it. So it's moving from P to Q, right? So it will be negative. So we are going to move O, Q, isn't it? And we are saying it will be positive there, then minus Q, X. Right? So let's have our OX is equal to OQ. What do we have on OQ? Good. Minus. What do we have on QX? No. Good. We've been given the expression. It's 1/3 of vector PQ. And PQ, you have found it, isn't it? Yes. So this is 1/3 of vector PQ. And we have found PQ, so our job is to substitute. So we have now OX is equal to Q vector minus 1/3. What is PQ? Right there. Which is vector Q minus vector P. Now we've been told to say this has to be expressed in terms of P and of vector Q as simply as it. So we have to simplify that. First we expand. So we have our minus this times that, vector Q this times that, 1/3 vector, isn't it? What do we do there now? Like terms. So which ones are like terms? Q and D? Good. So here we say this is same as what we have here. This is same as over 1. Someone is saying over 1? Huh? Okay, so let me explain here. We are saying we have Q minus 1/3 Q, isn't it? That's what we have, right? Yes. So if you factorize here the vector, meaning here you have 1 minus 1/3, then you have vector what? Q outside, isn't it? Yes. Small man. Old man. Small man. Eh? Pesa for one in our box the factorize. Multiplying here. Upper. Pesa. Here. We multiply which one and which one? Now Q. Now 1/3. That's what I've done. We said negative 1/3 times vector Q. Twasanga negative 1/3 Q, isn't it? Then we have negative 1/3 times negative P. Twasanga positive 1/3 vector P. There's no confusion? Okay. So here you are clear. We can move on. We can move on? Okay. So we are saying now we have Q vector minus 1/3 vector Q. These are like terms, isn't it? So we are saying we can factorize vector Q outside, right? Why have I factorized? I want you to see what is here, that we have 1 minus 1/3. So that it's not distracting you. So maybe the one very short, this is same as 1 1. Huh? Yes. Then you say, we want to find the lowest common denominator where 1 and 3 can go without giving you any remainder. Not the number that can go in 1 and 3, no. So what number is that? 3. 3. 1 into 3? 3. Times 1? 3. Minus 3 into 3? 1. 1 times 1? 1. Remember we have vector. So what are we getting here on top? 2 over vector. So this is what we are going to substitute here. This is what we are getting. So this one has given us 2 over 3 vector cube. This is for x. We are finding. Then we have vector, or we have 1 over 3 vector p. We have simplified. Okay? Where have you been? Huh? Do you know what you say? Huh? Shlemko? That's under CTA. Those under CTA? Abasai. Nuan? Achikengo. Number one is oh, say it, guys, say it. Okay, make sure you come back. Okay? Just hide. Okay. Sorry about that. We can continue. Now, we need to show the last question. We are told, given that. What have we been given? Given that O1 is equal to H O X. Now I want you to pay attention here. H is just a variable there, isn't it? Yes. It's not part of the vector. The vector is in O X. Show that P1 vector is equal to 1 over 3H. The variable is there now, minus 1. Outside, vector P is factorized, plus 2 over 3, that variable H, and vector Q has been factorized. So in short, they've told you the answer, isn't it? They've given you the answer. Now show them how they got to this answer. By way of using OY. So here, the first thing is, in short, what you have to look for is the P1. So find the path as if you are calculating P1. So this is number 2. So let's say we want to find the Py vector. How are we going to move? Let's create the path P1. P1. How are you going to move? P-O-O-Y. Where is P-Y first? Where is P-Y? P-Y. So how do we move? We want to move from P to go to Y, but there is no path there. P-O, then O-Y. And I know some of you can say, what if we just move P-X, then X-Y? That's what you are thinking, isn't it? Okay. And which is okay. But the question will be, do you have XY? So meaning first you need to calculate XY. And then now you proceed. That will be hard for you. So it's better to use what has already been given. You've been given OY, isn't it? OY has isn't it? Yes. Remember, we are moving from P to Y. So it's only that and then there. Let's substitute. Our Py vector is going to be, what is on PO? PO? Negative vector P. Good. Now minus. That's plus. What is OY? You have been given OY is H vector OX. That's what you have to use. They want you to use this for you to show that. Otherwise, you won't be able to show. So use where there is OY, we are told it's H vector OX. We are getting there. So let's proceed. We need to substitute OX, isn't it? Yes. So we have Py is equal to negative P vector plus H. What is OX? What have we calculated? OX is 2 over 3 vector P and vector Q plus 1 over 3 vector T. Now wonder we said you have to write this in its simplest form because you need to use it. So we have to substitute 2 over 3 Q plus 1 over 3 vector P. Making any sense? Yes. Yes. We proceed. We have now Py vector is equal to, we have negative P vector plus, let's multiply. We have to expand H times 1 over 3 vector Q. We have 2 over 3 H vector Q plus H times 1 over 3, that's positive H times positive 1 over 3 P, 1 over 3 H vector P. How do we proceed from there? Like this. Which one and which one? P. This one and that one, isn't it? Yes. So, as we are solving, we have to align ourselves to that. Okay? So, we are saying we are going to have P. Okay, let me use the black one. We can start with a positive, which is, we are saying Py is equal to 1 over 3 HP, isn't it? Then minus, that's vector P, right? We are saying H vector P, then minus P vector. What is remaining? Plus 2 over 3 H. We can look at the last part and we are getting there. Yes. Isn't it? Yes. This part, we are getting there. So what do we do here? What do we do? Factorize vector B. So we have Py is equal to, so if we factorize vector P outside, what are we remaining with here? 1 over 3 H minus 1. Then plus 2 over 3 H vector Q. Have we shown what we've been asked to show? Yes. Yes. So this is our answer. Hence shown. Hence shown. Any question?